This is a treatment of the advanced puzzle Distant Alp II, published May 31st of 2024. And it features a square with its diagonal, a 45-degree angle towards the midpoint of the top side, and two lengths, 3 and 4, along the diagonal. And we're asked to prove that those three red points are actually collinear. And I'm going to take the algebraic approach of Mr. Verdi Yilmaz-Turk. It's quite lengthy, so you have to bear with me. But then again, it's an advanced puzzle. Let's make the points visible. The first thing Mr. Yilmaz-Turk does is that he draws two vertical lines through that point and one through that point. And then it's a matter of placing length. Here we have 3 divided by square root of 2, which is easy from the 45-degree angle. Yeah, so you can basically you can transpose it over there, and then you see that this must be 3 over square root of 2. And exactly in the same way you get here 4 divided by square root of 2. Well, if I name this length from that midpoint to over here, let's say that is c divided by square root of 2. So that's, for convenience, I'll divide out the square root of 2 already. Then from the fact that it is the midpoint, so this must add up to this, we know that over there we have c plus 1 divided by square root of 2. That's quite obvious. And again, using the fact that this basically is a square, so you know that the diagonal, this must be 1 over square root of 2 times the diagonal, so we know that the diagonal must be 2c plus 1. Yeah, each time we translate a diagonal length to a side length by dividing or multiplying by square root of 2. Because we have this is a square, we know that this length equals that length, so we have that this is 2c plus 5 divided by square root of 2. We have here 2c plus 5 divided by square root of 2. Yeah, that's by equating this length to that length. Now I'm gonna name this length, this side, let's say it has length k. And now it's a matter of finding equations. First of all, the obvious thing is to use Pythagoras in this triangle. So k squared equals c plus 1 squared divided by 2 plus 2c plus 5 squared divided by 2. That's Pythagoras. Now I'm going to use similarity between the gray triangle and this triangle. Why is that? Because over here we have 45 degrees, that's also here, and this angle is shared between the two triangles, so we know that they must be similar. So this triangle is similar to the gray triangle. And what does that give me? If I divide those two sides, so opposing, so if, let's add that to here. If I divide k by 2c plus 1, then we know it must be equal, so that is long side to the middle side. Then in this triangle the long side is this, so it is 2c plus 5 is 2c plus 5, and the middle side again is k. Yeah, so that's an equation from the similarity of those two triangles. So if I rewrite that, you know that k squared equals 2c plus 5 times 2c plus 1. That's just rewritten. So we have found basically two equations for k squared, and we can equate them so we get one equation, one quadratic equation for c, if we just equate k squared with each other. So we can solve this quadratic equation. I will leave that to the reader, but basically there is one sensible solution, and that is c equals 2. It's a very straightforward quadratic equation. C must be 2. So very simple root. So basically what we found is that this length is 5. Yeah, 2c plus 1 is 5. Well, now the rest is quite easy. Here we have 2 divided by square root of 2, and here we have 2 square root of 2 from the 4. So we know that this is a 1:2 proportion. Yeah, so the if I say that here the angle alpha, we know that the tangent, using that c is square root of 2, and here we have 4 square root of 2, that the tangent of alpha is 1/2. But if I look at this, let's say if I look at this angle, here we have, so we had 5 plus 3, this total is 8, so here we have 8 square root, 8 divided by square root 2. So let's put that over here. 8 divided by square root 2. And here we have 4, well, we already found that, 4 divided by square root 2. So the angle over here, let's call it for now beta, the tangent of this angle, 4 divided by 8, is also 1/2. So there we have found that the 3 points are collinear, because those two angles are the same. And that concludes the proof of the puzzle Distant Alp II.